Hello friend, good morning and welcome back to your favorite technical channel AVM Tech Android. Today I am available with the first video lectures related to vapor compression refrigeration cycle, widely known as VCR cycle. This is a QR code of my channel and the channel name is AVM Tech Android. So either you can search AVM Tech Android on the YouTube, or just by scanning this QR code you can enter into the YouTube channel and you can see a sea of videos available at free of cost. So today friend, in current lecture we are going to discuss about vapor compression refrigeration system. In that we are going to discuss introduction part. In the next lecture we will discuss about the factors affecting the performance of VCR cycle, and after that we will discuss the numerical related to vapor compression refrigeration system. This is a very important topic for your subject as well as for GATE examination as well as for competitive examination. So friend, at present we have to discuss simple VCR cycle. Widely it is known as mechanical refrigeration system. If you refer some books, authors are preferred to write mechanical refrigeration system, that is nothing but a simple VCR cycle. And this simple VCR cycle is widely used for domestic and commercial utility viewpoint. So this mechanical refrigeration system is also known as VCR cycle, that is vapor compression refrigeration system. So if we'll talk about air refrigeration system, you find that COP of air refrigeration system is very low. So if we want to improve the COP and if we want to move towards the ideal value of COP, we have to go for phase change, or we have to introduce phase change in a cycle, and that is possible when we are talking about this VCR cycle. So in VCR cycle, the working medium or refrigerant undergoes a phase change during the cyclic process. So this is a very important thing. In the VCR cycle, working medium or refrigerant undergoes a phase change during the cyclic process. So some basic thermodynamic principle which we have to discuss for this simple VCR cycle includes: first, what we learn in engineering thermodynamics, that is heat will always flow from higher temperature to lower temperature, that is called spontaneous process. Second thing, the fluid absorbs the heat to change its phase from liquid to vapor, or when heat is rejected by the fluid, again that liquid is converted into solid, or you can say vapor, that will be converted into liquid. For the fixed value of pressure, vaporization of one particular fluid takes place at a constant temperature, widely that is known as a latent heat. The vaporization temperature at the constant pressure is different for different fluids. So this is known to us. So if you consider the fixed value of pressure at constant pressure, when the phase change is observed, at that time the heat, that is a latent heat, that is either supplied or that is taken from the system. Heat energy and other form of energy are mutually convertible with the directional relationship imposed by the second law of thermodynamics. So in the second law of thermodynamics, you know that there are two statements. One is known as a Kelvin-Planck statement and second is the Clausius statement. So now you try to find out which statement is applicable here. This is a very important thing. Someone will ask you which law of thermodynamics based on which simple VCR cycle will work. Your answer is second law of thermodynamics. But which statement? Clausius statement or Kelvin-Planck statement? So just you refer the previous videos of engineering thermodynamics. Links are available in the description box, and you try to find out simple VCR cycle works on which statement of second law of thermodynamics. This is very important. You try to find it out. Now we have to discuss about simple VCR cycle, that is vapor compression refrigeration system with analysis, which is widely known as mechanical refrigerator or fridge or domestic refrigerator, which is available at our home, as well as that is used for industrial application. So the major components of simple VCR cycle includes compressor, condenser, expansion valve and evaporator. So four major components are there: compressor, condenser, expansion valve and evaporator. So the fundamental processes which include in this cycle are compression, expansion, condensation and evaporation. Four component and four different processes are observed. So let us go with this simple VCR cycle. So in the exam the question may be there with a schematic diagram. Explain the construction and working of simple VCR cycle. So this is a schematic diagram of simple VCR cycle. The process 1 to 2, 2 to 3, 3 to 4, 4 to 1. It is a closed cycle and you can see it is operated in the counterclockwise direction or anti-clockwise direction. This arrow is very important. You have to put the arrow. If arrow is not there, examiner may not give any marks, because either it is moving in counterclockwise or it is moving in the clockwise direction. That is not clear if arrow is not there. So now we have to start with the first component, compressor. So you can see this is a reciprocating compressor. Work is supplied to it, means we have to supply electrical energy here. This is only a device which consumes electrical energy, which is generating a noise, which is consuming a power. And as you know, when we are talking about the compressor, it handles only compressible fluid. So definitely at inlet of the compressor, what you will observe, that is low temperature, low pressure refrigerant, that is in vapor state, because compressor cannot handle liquid, incompressible fluid. So what you will observe here is low pressure, low temperature refrigerant in vapor form that will enter into the compressor. You learn about the compressor at first level in the basic mechanical engineering. So what you will observe here is, at the end of compression process, what is coming out, that is high pressure, high temperature refrigerant in vapor form. Okay, so here the refrigerant is in vapor form, but its pressure and temperature is high. So this high pressure, high temperature refrigerant in vapor form, that will enter into the second device, that is condenser. So if we'll talk about our domestic refrigerator, in the domestic refrigerator, at back bottom side, one black device is available and which is creating a noise, which is painted black, that is nothing but a compressor. So generally in the domestic refrigerator, at back bottom side, black colored device is available which is creating a noise, which is consuming electrical energy or power, that is nothing but a compressor. Now the second device is a condenser. So high pressure, high temperature refrigerant in vapor form, that will enter into the condenser. This condenser is nothing but a heat exchanger, and in our domestic refrigerator, the heat exchanger or the condenser is located at backside. It is a net-like structure with uneven distribution of fins. You can see this kind of structure is available. It is again painted black. Okay, uneven distance, you can say this is uneven distance. Okay, this is a condenser. So in this condenser tubes, high pressure, high temperature refrigerant that is entering. And as we know that this condenser is kept away from the wall. You can say this is a wall of your house, wall of the room. And this is a condenser. So here the distance is observed where air is between the wall and the condenser. So air is a cold fluid, your refrigerant is a hot fluid. So this refrigerant will reject the heat. This is QR. Heat is rejected by the refrigerant. So what happens? It outlet of the condenser. Definitely heat is rejected. So temperature will drop. Pressure will drop slightly, or you can say pressure is as it is. But the refrigerant which was which was vapor here, that is converted into liquid because vapor reject the heat, so it convert into liquid. So you can see here high pressure, high temperature vapor refrigerant is converted into low temperature, high pressure refrigerant in liquid form. So at end of condenser, when the refrigerant is coming out, the state is low temperature, high pressure refrigerant in liquid form. All this thing what I am discussing is explained in the next slides. Now the next device which is available with us is the expansion device, or it is a throttle valve. So in a domestic refrigerator, generally the throttle valve is like a capillary tube. It is a spring-like structure and it is located at back side of the refrigerator just below the ice box. We can see it. This is the expansion device. So when the refrigerant will pass through this expansion device, what happens? Temperature is already lower. Pressure will drop in the expansion device and the refrigerant state is liquid. So when this is lower drop, okay, so when the refrigerant will flow through the expansion device, its temperature will drop. Its temperature is already low, pressure will drop and refrigerant state is liquid. So low pressure, low temperature refrigerant in liquid state is coming here at state 4. That is a state after expansion. And here the expansion which takes place is isenthalpic expansion. So enthalpy before throttling, that is H3, and that is equals to H4. Enthalpy before throttling and enthalpy after throttling remains same. It is isenthalpic process. At later stage we will discuss what is isenthalpic process and how we are representing it on pH diagram. So third device is also clear. Now we will move towards the fourth device that is evaporator. So this evaporator is nothing but ice box. So ice box is again a heat exchanger. So if you want to know basic about heat exchanger, in the description box the link is given about introduction to heat exchanger. It is equally helpful to all the level student of all the branch. You can refer it. So now what happens at inlet of the evaporator, low temperature, low pressure, low temperature, low pressure refrigerant in liquid form that is available, which is flowing inside the tube. Now what you have to do is you have to see your ice box. If you see the ice box, it is not flat one, it is embossed. So and for different company the internal design of the ice box is different, but definitely it is embossed. The material is a very good conductive material. Generally aluminum is used And when you open the door of ice box, one sticker is there which indicate that do not use any sharp object to remove the ice from the ice box. Okay, so it is a very delicate one. Inside the tubes refrigerant is flowing. So I am going with the next slide, so again we can clearly understand this part. So here low temperature, low pressure refrigerant in liquid form is entering. What we expect here, we want low temperature, okay, low temperature, low pressure refrigerant in vapor form, because this is the state at which the vapor is entering into the compressor. Here the refrigerant is in liquid form, here we want vapor. So system want to convert liquid to vapor. And now in the ice box, what we are doing, we are putting a tray of water. You can say this is a tray of water, tray which is filled with a water. We want ice. So liquid is available, we want solid, that is ice. So what happens now is the refrigerant will absorb heat from the liquid. When the refrigerant will absorb heat from the liquid, this liquid will convert into vapor. That is system requirement. And when the liquid will lose the heat, it convert into solid, that is ice. That is our requirement. So both the requirement will be fulfilled and the cycle will continue. So all the four components are clear. Compressor, that is painted black, located at back bottom side of the refrigerator. Condenser, that is a net like structure, painted black, back side of the refrigerator. Expansion device or capillary tube, that is again at back side of the refrigerator, spring like structure. Evaporator is ice box, where the condenser and evaporator both are heat exchangers. So this is about working of simple VCR cycle. Now you can see here lines are drawn, A and B line, or horizontal and vertical line. So again we will go through that. So what is that? So at state 1, what you will observe, low temperature, low pressure refrigerant in vapor state. What is available at state 2? High pressure, high temperature refrigerant in vapor state. What you will observe at state 3? High pressure, low temperature refrigerant in liquid state. What you will observe at state 4? Refrigerant is in liquid state with low temperature with low pressure. Okay, so now if I am drawing this line, horizontal line AA, what you will observe, above this line, what you will observe, above this line what you will observe, pressure is high. Bottom of this line what you will observe, low pressure. Okay, so above this line high pressure zone is there, below this line low pressure zone will be there. In this similar way, if I am drawing vertical line BB, and if I am talking about a right side of this vertical line BB, what I will observe, refrigerant is in vapor state, whereas here refrigerant is in liquid state, here refrigerant is in liquid state, means the phase change is observed. In the right side vapor phase is there, in the left side liquid phase is there. Okay, so initially we had discussed refrigerant is a working substance which is flowing through the entire system, which undergoes a phase change during a cycle. So what is refrigerant? Refrigerant is a working substance which is flowing through entire system and which undergoes a phase change is known as the refrigerant. So here you can see refrigerant is flowing through this entire system, and which undergoes a phase change like vapor and liquid. So this is about construction and working of simple VCR cycle. I hope it is very much clear to you. So all the thing what we had discussed, Q1 or QR, that is heat rejected, heat absorbed, that is QA, compression work, that is WC, above line A high pressure, below the line A low pressure, left side of line will be liquid refrigerant, right side vapor refrigerant. Now the compression process is shown here, what we have discussed, same thing is mentioned here. So we will not go in detail about all these things, what I had discussed, same thing is mentioned here. But what is the compression work? That is this compression work, that is H2 minus H1, that is enthalpy before this H1, that is enthalpy before compression, this is enthalpy after compression. So H2 value is definitely more than H1, and for the different state of vapor, state 8.2, either it is a superheated vapor or it is a dry saturated vapor, H2 that is equals to Hg plus Cp into T sup minus T sat, that is H2 that is enthalpy at state 2, that is equals to enthalpy of evaporation 8P2 pressure plus Cp of vapor refrigerant into superheat temperature minus saturation temperature 8P2 pressure, or if the vapor is dry saturated, then H2 that is equals to enthalpy of evaporation at P2 pressure. Again H1 that is enthalpy of refrigerant that is entering into the compressor, either it is a dry saturated vapor or it is a wet vapor. If it is a dry saturated vapor, then H1 that is equals to Hg enthalpy of evaporation at P1 pressure, or H1 that is equals to HF, that is enthalpy of liquid phase, plus X into HFG, where X is the dryness fraction. So again when we will solve this numerical, we will discuss about all these things again, but at present you have to remember work of compression, that is H2 minus H1, and the H2 that is refrigerant vapor, either it is a superheated one or it is a dry saturated one. H1 that is enthalpy of vapor at inlet of the compressor, either it is a dry saturated vapor or it is a wet vapor. So how to put the values, that is very important in case of the numerical. Again second process is the condensation process that takes place in the condenser. We had discussed about this part, so I will not go with all the theory which is mentioned here, just go through it if you want. But what is the amount of heat rejected? That is H3 minus H2. H3 that is enthalpy of the refrigerant at outlet of the condenser, H2 that is the enthalpy of refrigerant at inlet of the condenser. So H3 that is HF at P3 pressure, and H3 that is enthalpy of saturated liquid at P3 pressure at exit of the condenser, and H3 that is HF at P3 pressure, that is saturated liquid refrigerant at P3 pressure. Next we discuss expansion process that takes place in the expansion device. I told it is a isenthalpic process. You can see in the modern domestic refrigerator a capillary tube, that is small bore tube, is used in place of expansion valve. And during the throttling process, no heat is absorbed or rejected by the liquid refrigerant, and it is an isenthalpic process. So enthalpy before this expansion and enthalpy. Now for the throttling process, H3 that is equals to H4, And what is H4? That is enthalpy of wet vapor at exit of expansion device. And how to find out H4? That is HF4 plus X4 into HF4 at P4 pressure. Unit is kilojoule per kilogram, that is unit of this enthalpy. Okay, so how to find out this, again we will discuss when we will solve the numerical, but at present we have to remember that this 3 to 4 process is isenthalpic process, and now the last process, that is process 4 to 1, that is the evaporation process. And in this evaporation process, heat that will be absorbed by the refrigerant, you can see heat which is absorbed by the refrigerant is called refrigerant effect. So what is that value? So this refrigerant effect, that is the quantity of heat that each unit mass of refrigerant absorbed from the refrigerated space, is known as the refrigerant effect. And what is that heat absorbed? That is H1 minus H4. So H1, that is enthalpy of vapor that is entering into the compressor, and H4, that is enthalpy of refrigerant at state 4. Now if we want to know performance of refrigeration system, the term which we are using is COP. So COP, that is the coefficient of performance, and its value is effect divided by effort. So what is effect? That is the refrigerant effect. What is the effort? We have to provide electrical energy, we have to provide power, or we have to provide compression work. So it is RE divided by WC. So RE, that is H1 minus H4, and compression work is H2 minus H1. So coefficient of performance is not inverse of efficiency, and definitely the COP value is more than 1 here. So COP, that is a coefficient of refrigerant, that is refrigerant effect divided by compression work, that is H1 minus H4 divided by H2 minus H1. Now the question may be there in your exam. Draw a schematic diagram of simple VCR cycle and represent the same on TS and PH diagram. So just these 3 diagrams you have to draw, that's it. You should not write anything else. Okay, so this is our simple VCR cycle. Now we try to plot the processes on the TS diagram, that is temperature entropy diagram, and then pressure enthalpy diagram. So you can see our refrigerator according to thermodynamics, that is operated in counterclockwise direction. Heat that will be extracted from the refrigerator and that will be thrown into the surrounding. For that we have to supply compression work. So now 1 to 2 process is a compression process that takes place in the compressor. 2 to 3, that is heat rejection process. This is heat rejection takes place. Here compression work is supplied. So 2 to 3, that takes place in the condenser where heat is rejected. 3 to 4 is a isenthalpic process that takes place in the expansion device. 4 to 1, that is heat absorption process. Heat is absorbed in the evaporator. So 1 to 2 process, you can say rise in the temperature will be there. 2 to 3, constant temperature heat rejection will be observed. In the similar way 4 to 1 process, where again you will observe constant temperature heat addition process. So here and here latent heat will come in picture. If we'll talk about pH diagram, that is the pressure enthalpy diagram, then 1 to 2 process is the process that takes place in the compressor. 2 to 3 condensation, that is constant pressure heat rejection process. 3 to 4 it is isenthalpic process, you can see H3 that is equals to H4, and 4 to 1 again you can see it is a constant pressure heat gaining process or absorption process. So these two are constant pressure process, and here enthalpy remains same. So this is about schematic diagram of simple VCR cycle, representation on TS and PH diagram. This is our simple thermodynamic system for VCR cycle, and this is end of theory related to simple VCR cycle. Now if you have to compare the VCR system with air refrigeration system, for air refrigeration system, again refer the link in the description box. The link is available for the video lecture. You can see advantages here. COP of VCR system is higher. Running cost of VCR system is about 1/5 of air refrigeration system. Size of evaporator is small for the small value of RE here. Easily controllable expansion is observed in case of simple VCR cycle. These four are major advantage. If we talk about disadvantage, higher capital cost, leakage, inflammability, toxicity of the refrigerant, and effect of suction pressure is very important. If we talk about air refrigeration system, air is available at free of cost. If there is leakage or cost, it is less compared to this. So now at the end, again we'll summarize what we did. Initially we had start with mechanical refrigeration system or simple VCR cycle, in which we had discussed schematic of simple VCR cycle, location of different devices in the refrigerator or freeze, working of each and every component of simple VCR cycle, representation of simple VCR cycle on TS and PS diagram, and at the end we have compared VCR system with air refrigeration cycle. So this is about this video. If you like the video, then do not forget to subscribe this channel, like this video, and share this channel among all the needy students. Again, the channel name is AVM Tech Android. You can search on the YouTube, you can write this AVM Tech Android and you will get the channel, or just you scan this QR code and you can enter into this YouTube channel. Thank you very much.